Welcome back to Today Rocket Science. I'm Adam Balkin. The automobile has been transfixing young minds for over a century, from Henry Ford's Model T in the early 1900s to the NASCAR pros pushing the envelope on racing ovals coast to coast. But one group of students is taking that fascination to a new level and building their own race car and then sharing what they've learned with area students. It's a lesson they're sure to remember, seeing firsthand how the inside of a combustion engine works.
Normally people just see it and think it's cool because of how it looks, but when you see the inside and know how it really works, you could easily tell different things apart.
These college students at Cooper Union in New York City are sharing their engineering know-how with local middle school students from the Metropolitan Expeditionary Learning School, putting them in the driver's seat as they explain the inner workings of a car, from the engine to the building of its frame and suspension.
When we all saw the race car, we were like, whoa, you guys built this yourselves, and then you guys race it. Just seeing that they can make simple stuff and then it could be bigger and they could turn into bigger and greater things, that's really very interesting and really cool.
Being able to see that in real life kind of ties that concept together, and then being able to see that in a real life race car downstairs really gives them that excitement.
All of these college engineers are student members of the American Society of Mechanical Engineers and volunteer their time to give the younger students opportunities they didn't have before going to college.
We're passionate about what we do, and we never really had these experiences when we were in middle school, that young, being able to see exciting engineering projects. So we hope that we're able to instill some of that passion within them, and hopefully they'll be able to pursue careers and majors later on that relate to STEM.
It's cool because they know what we went through, because they're older than us, but it hasn't been that long since they've been into 7th grade.
It's this mentor approach to STEM learning that the students hope will spark a fire in budding engineers. One Ford exec we ran into at the Consumer Electronics Show earlier this year noted the importance of programs like these to get young people hooked on science, technology, engineering, and math.
The key is math and science, but I think even just as important where you were heading, just as important is to follow your passion. I like to share the story that when I was young, I loved to tinker. I loved electronics. And I wasn't getting enough from my education in my grade school to keep that passion alive. So I went and sought it out externally. And I guess that would be something I would encourage all of the students that might be listening to do the same.
And under that same enormous CES roof, we ran into another organization helping young builders get an early jump on mechanical engineering through robotics and programming. It's called VEX Robotics, and it's an educational engineering competition for students of all ages.
Our kits are designed for students to be able to build, program, learn STEM concepts. We've got a free online curriculum available. That's my job as education manager. That curriculum even drives down as low as 2nd grade.
The goal of this competition, to get the robot to pick up these balls and score with them.
This is our basic Clawbot, little tank drive robot. Our kits come with building instructions for Clawbot for, the beginning of learning about robotics.
Robots come with default programming, but students can create their own programs for the bots as well. But Rich says while the experience is fun and sometimes hard work, the focus is on the future.
There's clearly a lot of call for inventors, thinkers, problem solvers down the line. Our mission really is about, feeding the STEM education pipeline, getting kids as young as possible to understand the concepts, do that hard learning while they're having fun and doing something visceral at the same time.
In Texas, students are learning to engineer in another way, taking their love for building and games and applying it to engineering software for video games as part of their school's curriculum. Here's hoping they make the grade. Rex Castillo has the story.
If you walk into this school, it doesn't look like your traditional classroom. What these students are learning is far from conventional.
We're actually designing real games that you can actually go through and play and enjoy.
And the tools these students are using in the classroom are easily recognizable.
So they are using Xbox 360s to do 3D scanning, and they're using motion capture, mocap for short, to capture real-time live data so they can take that data and put it on an animated character and animate it in real time.
It's a lot of the same software the pros use.
This is what the industry is using now, and so the students they're having a wonderful opportunity here at this high school to be able to learn this now so they can jump right into the industry at some beginner level and get more experience when they're on the job.
Students are involved in every aspect of the video game, from programming to the way their characters look. Many now know what it takes to create the games they love to play.
And you have a lot more respect for the people who do it, because it's a lot of work. Even if they have like a lot more people and a lot more time, it is a lot of work.
Work that students say keeps their attention more than traditional classes. These students believe their projects can create childhood memories for future gamers.
I feel like I'm helping the next generation along, because video games are just such a memorable thing.
For It Ain't Rocket Science, I'm Rex Castillo.
We have to stop here for one more quick break. Then coming up, what's it take to build a skyscraper? We'll talk to an architect who's working on one of the tallest, if not the most slender, of buildings in New York City. And future building designers become urban problem solvers as city planners. To find out more about science, technology, engineering, and math opportunities in your community, remember, visit connectamillionminds.com during the break.